Welcome to my channel. In this video, we will see what are the rules for obtaining images by spherical mirrors. The components of spherical mirrors was discussed in my last video. When an object is placed in front of these spherical mirrors, an image is formed at that point where two reflected rays will intersect or appear to intersect. To find the position of the image and nature and size of the image, we need to know what are these two rays which are intersecting, and in order to do that, we will see the following rays which we call them as rules for obtaining images. I will be showing you here both concave and convex simultaneously so that we can understand it better. Number one, a light ray which is incident parallel to the principal axis. A light ray which is incident parallel to the principal axis. Now let us see first the case of concave mirror. So this is the concave mirror, Mn is the concave mirror, P is the pole, F is the focus, C is the center of curvature. Now XP forms the principal axis. Now a ray parallel to the principal axis is, let us say, AB, like this, and that when it is incident on the surface of the mirror at the point B, it gets reflected along BY. So BY is the reflected ray, AB is the incident ray, which passes through the focus F, Now here, because the incident light is at this point B, the line joining B and the center of curvature will form the normal to this. Therefore, this is your angle of incidence I and this is your angle of reflection R. So the line joining the B and C forms the normal. Now at the point B, any light which is incident, it actually looks like this. If this is the concave mirror and if a light is incident at this point, it actually becomes, when you draw a tangent like this, it becomes a normal. So it gets reflected and this is the normal, and that I have shown you here. So AB is the incident light ray parallel to the principal axis and the reflected light passes through focus. So that is the important point. Now the same situation let us see in the convex mirror. AB is the incident light and when it is reflected, it appears to come from F. So the line appears to come from F. Therefore, BD is the reflected light, AB is the incident light. Again, the line coming from C will form the normal N. So this is your angle of incidence I, this is your angle of reflection R. That's the first rule. Now second rule, coming to the second rule, here it is a light ray passing through C, a light ray incident passing through center of curvature. Now P is pole, F is focus, C is center of curvature. Now ACB is a light which is incident on the surface MN and it falls normally at this point B, and therefore BC is the normal, and therefore what happens? The angle of incidence is 0 and therefore angle of reflection will be 0 and it retraces its path. So BCA. So I have shown you the direction incident light and the reflected light, which means it retraces its path. So ACB is the incident light, BCA is the reflected light. Why it reflects in the same path? Because any line passing through the center will become the normal. Therefore, when it is the normal and in the same direction the incident light is coming, obviously angle of incidence is 0, therefore angle of reflection will also be 0, and hence it retraces its path. Same is the case for convex mirror. Let us see. A, B, C appearing to come from C. So if I consider that light, so A, B, C is the incident light directed towards C. And obviously this becomes, BC becomes the normal, and therefore angle of incidence, for the same reason that I explained, I is equal to 0, and it retraces its path. So it is the incident direction, it is the reflected direction. So it appears to come from C. Then the third rule is a light ray, again from concave we are discussing, a light ray incident passing through the focus F. So passing through the focus F. Now look at this. We have the principal axis just like what I have discussed earlier, XP, F is a focus, C is the center. Now a light ray which is passing through F, that is focus, is incident at the point B on the surface MN, which means AB is the incident light. AB is the incident light. BY is the reflected light which will be parallel to the principal axis. This is principal axis. So BY is this. So BY will be parallel to the principal axis. Now if you join BC, that becomes the normal. So this is angle of incidence, this is angle of reflection. Now when you closely observe this, this is exactly the reverse of rule 1 which we have discussed above. Here a light which is parallel to the principal axis is incident and the reflected ray passes through the focus. Now here a light which is passing through the focus is incident and the reflected ray will be parallel to the principal axis. So AB is the incident light, BY is the reflected ray which is parallel to the principal axis XP, and BC becomes the normal, any line passing through C. Now let us see for the case of convex mirror. Again, a ray AB which appears to come from F or directed towards F is incident. This is the AB, incident light. Then a line passing through C becomes the normal, and it actually gets reflected like this in this direction, so which will be parallel. So this is the reflected light. So this is angle of incidence, this is angle of reflection. So AB is the incident light, let's say BC is the reflected light, or BC we have used it here, so let's use D. So BD is the reflected light which is parallel to the principal axis. Then rule number 4 is a light ray which is incident at the pole, that is point P, clearly. So far we have seen it at any point on the surface of the mirror. But now let us see a light ray which is incident at the pole P, or we can say, for example, oblique incidence to principal axis at P. This is, which means a light is incident at P. AP is the incident light ray, that is oblique incidence at the point P. Now, therefore, the light gets reflected, and it will be reflecting with the same angle as that of the incident light. Now the principal axis itself will become the normal. It becomes the normal. So angle of incidence I, angle of reflection R. BP is the reflected ray. Now let us say if the incident light is not having oblique incidence, but it is incident along the principal axis at P. So this light P, F, C. So this is the one, which means if this light is incident along this, now my point is if this light is incident along this, now this is the incident light CP, Now our condition is a ray of light which is incident at the pole P. That means pole P, it is incident, but it is along the C in this direction. Even this is an incident light, but because it is passing through C, it becomes the normal. Therefore, angle of incidence I becomes 0, angle of reflection R becomes 0, and it retraces its path. So this becomes its reflected, same ray reflects. So same is incident, same is reflected. Now in this case, convex mirror, it is simple. We can see that AP at this is the PFC stand for the standard notation. Then AP is the incident light, oblique incidence at an angle I. Then this forms the normal passing through C, and then this is the BP, refers to the reflected light which reflects at the same angle. So that is important, reflection at the same angle. So what we have discussed so far, we have discussed 4 different rays. One is parallel to the principal axis. This is rule number 1, parallel to the principal axis. So what will happen? The reflected ray will pass through focus. Then ray through C. The second one is passing through C, and you will have retracing its path. So it's the same will be. And third one is passing through F. So you will have reflected ray which is parallel to the principal axis. And when you have an oblique incidence at P, that means the light is incident at the pole P, then you will have the reflection from the point P with the same angle. So these are the 4 rules, we can call 4 rays. Now using these 4, we will be able to see the intersection of any of these 2 which will form the image, and therefore we can study the images formed by any of these 4, and any 2, basically we need only 2. So any 2 from these 4 rules will intersect when an object is placed in front of the mirror, either concave or convex. Now how these images are formed with these rays and what is the nature and size of those images, we will see in my next video. Until then, keep watching, keep learning. Thank you.